All right, so I've got my triangle. I've got my two remote interiors, 1 and 2. 3 is just the other interior. 4 is my exterior. And the goal is to show that 1 plus 2, these guys added up, is 4. Now, one of the first things I told you when we took on this proof, and I assigned it, was that this was a corollary of the triangle sum theorem. So let's start there. What does the triangle sum theorem say about this triangle? Okay, so I add up 1, 2, and 3. I get 180 degrees. That's from the triangle sum theorem. Right? I gave you another hint. The book says, hint, AB, BCA, and DCA, that's angles 3 and 4 in our diagram, form a linear pair. So what do you know? Forget everything else. Let's just look at 3 and 4 first. Up here? Yeah, I could draw that in. And that proof wouldn't be wrong if I did that. But it's going to be a lot longer. So, because that imaginary line is part of how I proved this. So if I introduced it, I'm just adding a lot of steps. It's true, but again, it's going to make things a little lengthy. But let's start with that supplementary you mentioned. If 3 and 4 are supplementary, so angle 3 and angle 4 are supplementary, that's by the linear pair theorem. What do I know about them? Forget everything else I've said. Just boom. 3 and 4 are supplementary. What's the next logical thought? Exactly. Measure of angle 3 plus measure of angle 4 equals 180. That's by the definition. Even if I don't use that in the proof, it doesn't hurt to mention it. You know, it may have nothing to do with the argument at hand, but you never know. It might be a useful thing to have out there in play. It might not be wholly relevant how much money was donated to a given political campaign. So if we're talking about reform in politics, well, let's get the information out there. If it becomes relevant, we've at least got it out in the conversation. If it's not, well, we didn't waste too much breath or ink on it. However, now I'm still kind of stumped. Well, let's say I've got 1, 2, and 3 equal 180. I've got 3 and 4 equal 180. I've seen proofs that do that before. What do I usually do when I see that? Substitute, yeah. I've got one thing equals something. Something else equals the same thing. Let's plug it in. Measure of angle 1 plus the measure of angle 2 plus measure of angle 3 equals measure of angle 3 plus the measure of angle 4. Substitution. Or what else might I call it? Transitive. Transitive property of equality. Either one works. My goal is to say that 1 and 2 equals 4. I always should be thinking about where I want to end up. Can I get there from here? Covers. What am I subtracting? Yeah, knock those guys out. So measure of angle 1 plus measure of angle 2 equals measure of angle 4. Subtraction property of equality. That is what I set out to prove. Shoot.
Why did I
You drew the parallel line.
Yeah, no, but that's not it. I started off with and then I did the point A, zero, the line and what was that theory?
The parallel postulate says that there is a line that's parallel, which will create some angles that you can work with. I'll take a look at your proof step by step with you later to see if you at least broke the rules anywhere. Theoretically, if you started here and you got here and you didn't break any rules, it's not wrong. Although, bear in mind, the one catch with the way we're doing this is you do have to recognize this step because on the fill in the blank, you got to follow the format. That's the unfortunate twist we saw. But I'll take a look to see if your proof looks okay. So at least you've got a good understanding of the theorems.